All right, so here's the next screencast for the chemical reactions unit. This is objective number 3. Describe the steps for writing a balanced chemical equation. Basically, we're just going to learn how to balance equations, which is something that you learned how to do in physical science. This is something that should not be new to you. If it is, you might need some extra practice at it, and we're going to do some more practice in class. But just a heads up, I'm going to kind of go through this quickly. So we're going to talk about moles and coefficients. We're going to review what subscripts are. It's just what are the steps involved in balancing chemical equations. So when you balance a chemical equation, just like it shows you up here, you want everything to be the same on both sides. So you want your number of atoms for each element to be the same on both sides of the equation, which is why you'll see coefficients like the coefficient in front of oxygen or the coefficient in front of water to make it balanced. So a balanced equation, it describes the reaction. It follows the law of conservation of matter. So you have the same number and type of atoms on both sides of the equation. So you are not violating that law that says that you cannot create or destroy matter. So you have to have the same number on both sides to show you're not creating or destroying anything. Can only be balanced by changing the coefficients. It shows how many compounds are involved in a reaction. I am not going to change the actual formulas for the compounds. So CO2 will stay CO2, water will stay H2O, oxygen will stay O2, methane will stay CH4. I'm not going to change the formulas. I just add coefficients in front to balance them. So we have special symbols to indicate the physical state, as well as if a catalyst is required. You might see the physical state listed after for like a solid, liquid, or a gas, or if something is required, you might see it written on the line for that chemical reaction. So coefficients, remember, they get multiplied by these in front. They're going to be the large numbers in front of a compound. They indicate how many compounds and how many groups of compounds you might have. And that number, that coefficient in the front, is literally telling you how many moles you have. 1 mole is 6.022 times 10 to the 23rd atoms. So if I say I have 1 mole of water, that means I have 6.022 times 10 to the 23rd atoms of water, or molecules of water. And that is what the coefficients in the front means. This right here is a little foreshadowing for our next unit, our stoichiometry unit, where we're going to take chemical reactions one step further. They are not subscripts, and you need to remember that. The subscripts are the little numbers at the bottom. Those tell you how many atoms are in that compound or how many atoms of each element there are, but not how many of that whole compound that you need. So subscripts don't change when you are balancing. Once you've written the formula doesn't change. You're just going to put numbers in front to change the number of atoms. So basic balancing steps. The first thing, this is kind of how I always tell everybody to do it. Count the number of atoms on each side. Just make a list, so that way you know what elements you have and how many of those, how many atoms of that element you have. Balance your metals first, then do your polyatomic ions and your nonmetals. If your polyatomic ions are on both sides, you can keep them together. Then do hydrogen and oxygen last. Those are normally going to be free, like not combined with anything else. So do those last. And then make sure you go back and balance any element that you happen to unbalance along the way. Here's a couple of hints for you. Leave the simplest elements for last, because these are usually the easiest to balance. Count polyatomic ions as a unit, as long as they are on both sides. And if you can't get a diatomic element to balance, just double it. Make something even. If you have 3 on one side, double it. Put a number in front of it, put a 2 in front of it, so now you have 6 of that element to make it an even number. It just takes practice. So this page is some practice, and if you know how to do this or are confident doing this, I want you to practice these. So write these down in your notes. We will do these examples in class together, but I want you to try them on your own. If you are not able to do these, I have created an EduCreations video where I balance the first one, so aluminum plus oxygen yields aluminum oxide, and I also balance this fourth one here for you to show you kind of the steps or the procedure for balancing a chemical equation. I want you to practice balancing these before you come to class. Don't worry about identifying the reaction type, as we have not done that yet. The next slide just tells you what we're going to do in class. We're going to work more examples of writing a complete chemical equation and balancing. We're going to practice on the whiteboards if we need to. I do have a balancing equation worksheet that we are going to do where everybody is going to get practice. There is a quiz that you are going to take. You're just going to take and report your score, and we will do this in class. So the summary for objective number 3 is template number 1. So you can go ahead and complete that before you come to class, and that's all you have to do for objective number 3.